Alright, guys, this is the last podcast we're going to do here. This is only for the advanced classes, so 4th and 6th period. Basically, what we're going to do is we're going to do a mixture of stoichiometries. So, we're going to go from mass to particles, particles to liters, and then liters to mass. Okay, so here's our first question. It says, how many particles of O2 are produced when a sample of 29.2 grams of H2O is decomposed by something called electrolysis. Basically, what that is I'm breaking apart water with electricity. Um, so it's decomposed by electrolysis according to the balance equation. So I provided the balance equation here for you. So let's go ahead and set that up. So go ahead and take out your stoichiometry map if you don't have it already out. Um, so let's try to figure out what we know. We know that we have 29.2 grams of H2O, and we're trying to find particles. So I'll put particles question mark of O2. And what we're going to do is we're going to go ahead and set. So we set this up by going 29.2 grams, and that's a H2O. Okay, so the trick is we're going to go from mass to mole, and then mole to particles here. Okay, that's the path we're going to follow. So right now we're right here, so we're going to go to moles. So when we go to moles, what we do is, remember, you put the 1 mole on top, and then you put grams of H2O on the bottom. H2O is going to weigh 18.02 grams. Okay, so now we're at the mole part, so I have to go from mole to mole. So I have 1 mole of O2, and then we have 2 moles of H2O on the bottom. And then our last step is we go to mole to particle. So now I'm going to go ahead and put 6.02. Oops. I hate when that happens. 6.02 times 10 to the 23rd on the top. And that's of O2. And then we're going to go ahead and put 1 mole on the bottom. O2. And then our equal sign. So we did our 1, 2, 3 step. The only problem, or the only difference is really, instead of going mass to mass, we went from mass to particle. So let's go ahead and figure out the answer to this question here. Yeah, 29.2 times 1 times 1 times 6.02 times 10 to the 23rd. And then we will divide it by 18.02 equals, and then divide again by 2. And my answer that I got, using the correct number of significant figures, should be 4.88 times 10 to the 23rd, then particles of O2. That's the first one. Let's go ahead and look at the second one. This is particles to liters now. This formula isn't down, so we're going to just go ahead and balance it. 3, 1, 2, then a 1. How many liters of NO2 must react with water to produce 5.00 times 10 to the 22 molecules of NO? So I have my particles. I'm looking 4 liters of this guy. Let's go ahead and set this up real quick. We got 5.00 times 10 to the 22 molecules of NO. Let's set up the chart. We're going from particles to moles, so I'm going to put 1 mole on the top. 6.02 times 10 to the 23rd on the bottom. Now we're going to do our mole to mole ratio. We have a 1 to 3. So what we're going to do is I'm going to go ahead and I'm going to put 3 on the top. We're going to put 1 on the bottom. And now I'm going from moles to liters. So we're going to go ahead and set that up. I put 22.4 on the top, liters, 1 mole on the bottom. And then our equal sign, now we go ahead and solve this problem. So we have 5.00 times 10 to the and then we're going to go times 3 and then times 22.4 and then divided by the 6.02 times 10 to the 23rd equals, and then using our 3 significant figures, our answer should be 279 liters of NO2. Okay. Alright, last one. Here we go. This is liters to mass. It says what mass of mercury 2 oxide. So we're looking for this in mass is required to produce 812 liters of O2. Okay, at XTP, so it's just like standard temperature and pressure. It has nothing really to do with the problem. We're gonna balance it first. 2, 2, 1. And we're gonna go ahead and set it up. So we have 812 liters. And we're gonna put 1 mole over 22.4. And then we do our mole to mole ratio. We're going to go put 2 moles on the top, 1 mole on the bottom. And then the last step, I have to figure out, well, how much does HGO weigh? Let's see. Yeah, mercury is 259. Yeah, oxygen is 16. So 216.59 over 1 mole equals sign 812 times 2 times 216.59 equals divided by 22.4 equals, so that's going to be a lot of mercury 2 oxide. It's actually going to be 15,700 grams. And that's it. That's basically the end of right now. Feel free to watch these over and over again so that you can get a better idea what you're doing. If you have any questions, just let me know.